Here's example 4 from your Redox worksheets. So this one's an acidic solution. First thing I'm going to do is assign oxidation numbers so I can figure out what's going on. So assigning oxidation numbers has a video also. If you can't remember how to assign oxidation numbers, you can go back to that. Oxygen has a -2, but there's 3 of them, and I need to have a total overall charge of -1. So nitrogen has to provide 5 pluses. This is 2 plus. He's in his elemental state. He's 0. And nitrogen here is +2. So the things that are changing are sulfur and copper. Now remember, you can only break up the things that you can ignore are spectator ions. So spectator ions have to be ions. So they can't be part of a polyatomic ion and they can't be part of a molecule. So if it is an ionic compound and the either cation or anion does not change oxidation numbers, it's a spectator ion, you can ignore it. Same thing as if it's an acid. So let's go here and split these up into half reactions. Sulfur goes from -2 to 0, so its charge increases. So it's losing negativity, therefore it is losing electrons, so it is oxidized. And then we have nitrate, NO3. We can't break up this polyatomic ion. We can't break up polyatomic ions, and we can't break up molecules. I know this is a polyatomic ion because it has a negative charge on it. I know this is a molecule because it's got 2 nonmetals bonded together and has an overall charge of 0. So the first thing we have to do is balance everything except for oxygen and hydrogen. That's already done. Next thing we need to do is add waters to balance out oxygens. So here I have 3, here I have 1, so I need to have 2 additional ones. Next thing I'll do is add H pluses to balance out the hydrogens like such. So now I should be balanced according to mass, meaning that my atoms on the reactant side are going to total up to the same amount as the of atoms on the product side. Now we have to add to charge. So remember, we only have electrons to work with. So we're going to bring the more positive side down to the more negative side. So I have a total of -2 on the reactant side for sulfur and 0 on the product side. So I'll add 2 minuses to the product side. This next reaction has 4 pluses and 1 minus. So it's a +3 on the reactant side right now, and it's 0 on the product side. So I'm going to add 3 electrons to bring it down to 0. So -3 + 4 - 1, that's equal to 0. Same as the products, I'm good. Remember, I have to double check. If I get electrons on the same side, I've made a mistake. So now I need to look for the lowest common denominators because electrons cannot be created nor destroyed. I have to have the same number of electrons lost as I have gained. So the lowest common denominator between 3 and 2 is 6. I'm going to rewrite these down here now. Make sure you distribute that 3 throughout the entire reaction. Now I'm going to make sure I distribute that 2 to the second one. So let's just keep ourselves straight here by underlining everything that's in the reactant side in blue. And everything that's in the product side will underline in green. If there are things that are the same on the reactant side and the product side, you can cancel them out. So I'm going to look and see 6 electrons on the reactant side, 6 electrons on the product side. That's the only thing that is the same. So now let's rewrite this and it'll be our final answer. This is in acidic solution, so I'm done after this one because I do have H pluses. Acidic solution means I have H pluses available to use to balance this because the chemical reaction used it. And that's my final answer for the balanced equation that occurs in acidic solution. Now everybody always says, what about that copper? Well, it didn't take place in the reaction, so I don't have to put it back in if I don't want to. And on the AP exam, they will not expect you to consider spectator ions at all.